Hello everybody, I hope all of you are doing good. So today I'm going to talk about algebra. Okay, so I'm going to start with very basic stuff, that what is algebra. Okay, before we get into algebra, right, let's understand what did you learn till now. If you are a student of class 6 onwards, right, you might have dealt a lot with arithmetic, right? Arithmetic was all to do with numbers, right? Different types of numbers and operations. When I say operations, what do you mean? Plus, minus, multiplication and division. You have dealt with a lot of numbers like whole numbers, right? Whole numbers, natural numbers, integers, rational numbers, irrational numbers. So these were all numbers, right? These are all from the family of real numbers, right? What are real numbers? Real numbers are numbers. These numbers can be shown on a number line. We have a number line. We can show all these numbers on a number line, right? So you dealt with a lot of numbers. All these numbers, whatever you dealt with, right, they are known as constants. They don't change. Constants means they don't change. If I tell you that 4 plus 5 will give you 9, right? Nothing changes over here. Number 4 doesn't change, number 5 doesn't change, and number 9 doesn't change. Right? These are known as constants. You cannot change them. Similarly, like 9 minus 7 equal to 2. 9 divided by 3 equal to 3. You have done this basic math. And then what you did? You learned multiplication, subtraction, your addition and division of larger numbers also. Larger numbers like any number. For example, 4, 5, 7, 9 plus 2, 3, 8, 1. Right? 0, 6, 8, sorry, this is 9. This is 9 and 6. Right? So you have done a lot of maths around it. The same thing can be done, like you would have done a multiplication. You have done a big division. You can divide, you can subtract. You have done a lot of all these things. But till now what you are doing is that you are dealing with all constants. Those numbers don't change, right? So what happens in real world is that we will use numbers in the real life applications, but at the same time I cannot basically assign any different value to that, right? That is where algebra comes into pictures. Algebra deals with something called variables. What are these variables? Variables means vary. Vary means the number changes. You can change the number. You can change the number. In algebra, what we do is that we deal with alphabet. Suppose temperature of a city. If I put it as 25 degrees centigrade, it remains. Do you think that the temperature remains the same throughout the day? No. So I cannot put it as 25 degrees centigrade may be the temperature at a particular time of the day. It can happen. 25 degree can change. It can be 25 degrees early in the morning. It can be 25 degrees late in the night, and it can be 25 degrees in the afternoon also. But it doesn't remain constant. This is what we talk about constant when we talk about arithmetic, right? Now, if the weather department has to track the temperature of a city, right, they will use a variable called T. They will give an alphabet to that particular term so that they can track the temperature throughout the day. Now this variable, what happens is that, say 6 o'clock in the morning, the temperature is 25. right? Say 6:30 a.m. It is say 28 degrees. Say 7 o'clock in the morning. 7 o'clock in the morning it changes to 30 degrees. As and when we keep going, right? 12 noon. 12 noon. What happens? It can be around 40 degrees. Similarly, when it keeps coming down, right? 9 p.m. in the night, it might be again 25. So look at it, how many values it can take during the day. So what happens is that this T, the variable which has been assigned to the temperature of the city, can take multiple values during the day. And what we do is that we save those numbers at that particular time. As constant temperature. So that is how we basically store the temperature in the system, to tell the people that this is what the temperature during the whole day on this particular date, right? That's why we use variables. So variables means this alphabet what we have assigned to this term, right, temperature, can take multiple values in a day. Okay, so that's where algebra comes into picture. Algebra is very useful. It's very useful for on a day-to-day basis to design a lot of programs. Okay, we use computers, we use programs, we have to write a lot of logic in the programs, and we use variables to basically store the data. This data which I spoke about. Okay. Now another example. For example, if you take a speed of the car. Speed of the car on a highway. I'll assign a variable called speed. So when you start from home, right, you might be driving at only 10 km per hour. Right? As in when you keep going, you increase it to 20 km per hour. At the moment you hit the highway, you might be driving at 60 km per hour. Further, when the highway is very free and if the speed limits allow it to go till 80, we'll go till 80. Similarly, when I'm coming down, right, when I come back home, right, I can again reduce it down. So look at it. My speed keeps changing throughout my journey. So I cannot store only one value in that particular. This S can have multiple values during the time of the day. Understood? This is what the basic difference between arithmetic and algebra. Arithmetic deals with a lot of constants and algebra deals with a lot of variables, remember. So going forward, as and when you keep going to higher classes, you are going to do a lot of algebra. And this is where algebra deals with constants plus variables. Constants plus variables. For example, if I want to write an equation like this, look at it. Okay, so now in this particular case there are three variables. Okay, if I take those variables as, suppose you're sitting in a room. I just draw a rough picture. You're sitting in the room. So you will have a length x, okay, you'll have a width, say y, and you'll have a height, say z over here. Now what happens? The room size might change, right? Home to home, even in your home, all the rooms may not be having the same length, same width or same height. So what happens is that when we do constructions, right, when the builders construct homes, right, they will assign them variables so that they can take different values. Okay, so that's why these are known as variables over here. Now if you look at this one over here, it's a constant. This will not change. The number is already assigned. They are saying this is 2 times x. This is nothing but it is known as 2 times x. Means if the length of the room is 10, right? Suppose x is 10. I can put it as like this. This is nothing but 2 times 20. 2 times 10 is 20. Okay, so these are known as constants. These numbers are known as constants which will never change. But these are your variables which will keep changing. Remember that one. I hope you're getting the picture, what I'm trying to paint, right? So understanding these basics will help you to understand algebra very well. Algebra is a little bit complicated. I don't want to scare you, but if you understand the logic well, your life becomes very easy. Okay? Now look at it. You can multiply two variables, right? I can write it as like this, x, y. These are two different variables which is nothing but this is x times y, if you look at it. Similarly, I can add two variables. Okay, this is the same as x plus y, no changes. I can subtract two variables, right? It's the same. And similarly, I can divide. I can divide like this also. So they are same, all same. Okay. In this particular case, it doesn't matter. If I do this one, right, that associative law, it works. If you look at it, you might have learned that associative law that works over here. But even in this one, it will work. X plus y is equal to y plus x. They are both same. These two are same. But is this going to work? X minus y is not equal to y minus x. Remember, these two quantities are not same. Why do I say that? Let's put some values. Let's say x is equal to 6 and y is equal to 7. So if I do here, right, 6 minus 7, I'm getting minus 1 over here on the left side. When I do x minus y, I'm getting minus 1. When I'm going to do y minus x, if I do y minus x, what do I get? I get 7 minus 6 is equal to 1. If you look at it, right, these two values are not same. That is what I'm trying to make you understand over here. Okay? So, you need to understand that what we are doing over here. Similarly, x divided by y, x divided by will not be equal to y divided by x. Again, take an example. Suppose x is equal to, for left hand side, right, I put x is equal to 4 divided by 2. So what do I get? 4 divided by 2, I get 2. But similarly, if I do over here, 2 divided by 4, am I going to get 2 divided by 4 will always give me a fraction. See, these two values are not same. So that is what I was trying to explain over here. Hope this is clear, right? Okay. Now let's move forward. Let's understand some more basics about algebra. So if I have an equation like this, equation is nothing but we call it an equation, right? Whenever you have multiple terms in a particular equation, suppose I write it like this: 4x square y square minus 3xy plus 7z square. So how many variables are there first of all over here? The first thing you need to note is that how many variables are there? There are only 3 variables. Variables, if you look at it, if I want to know, there are only 3. X, you have y, and you have z. Okay? Don't worry about these squares over here. This is nothing but, this x square means what? X square is nothing but, it is x times x. Y square is nothing but, it is again y times y. Similarly, z square is nothing but, it is z into z. Right? So, but the variable is only one. You don't count them twice. The variable is only one over here in this particular case. Okay? Make sense? Okay, let's move on. Now, let's understand. Now, this is an equation. This is known as an equation basically. We call it an equation over here. Okay? So, what happens over here? If you look at this particular case, this is one term. This is known as one term. Okay? Similarly, this is another term. This is the second term over here and this is the third term. So this particular equation has 3 terms. 3 terms over here. Look at it. The first term is when there is no sign in front of a term, it's always positive. For example, even in numbers, right? When I write just number 2, what does it mean? It means plus 2. It's always plus 2. And for a negative number, we specify a negative sign always, right? Similarly, in algebra, signs, the plus sign, minus sign plays a very big role. Remember this one. Don't miss out on signs over here. So in this particular case, what's my first term? First term, if you look at it, it is plus 4x square y square. What is my second term? Including the sign, you need to remember, always take the sign along, 3xy. What's the third term? It is plus 7z square. Okay, got it? Makes sense? Now look at it. They will ask you certain. Now let's understand what is a coefficient. Coefficient. What's a coefficient? Okay, if they ask you about the coefficient, is something which is in front of that particular term. What is a constant over here? This is constant, this is a constant, and this is a constant. What are your variables? This is a variable, this is a variable, and this is a variable. All three are variables. Okay, they are multiplied with each other. Don't worry about that one. But if you look at it, your numerical coefficient is the constant. In this particular case, your numerical coefficient, if they ask you a question that what is the numerical coefficient of this particular term, it's plus 4. Similarly, what is the numerical coefficient of this term? It is minus 3. And similarly, here it is plus 7. But for example, they might change the question and they ask you that, can you give me the coefficient of y square? Only y square. If I close this one, whatever is left, right, that is your coefficient. So in the first term, coefficient of y square, in this particular case, just close y square, whatever is left, that's your coefficient. Remember this one very well. Similarly, here coefficient of, say, x only. X, only x. So what I'm going to do, I'm going to close this. What is left? I'm left with minus 3y. That's your coefficient. So these are known as numerical coefficients because they are asking only about the number which is there in front of the term. And these are coefficients if they mention these. Like in this particular case, right? Coefficient of, say, only z. Only z. Do you have a z, only z over here? Yes. I can write this as z into z. I can write this 2 times. So if I close this, what am I left with? I'm left with plus 7z. So that's your coefficient. Make sense? So this is very important to understand algebra as and when we keep going. Okay? Great. Okay. Now, before moving forward, right, I want you to understand the signs, how to operate and signs, the signs, right, basically the plus and minus, how do they operate. You might have done a lot of arithmetic related to signs. If your concepts are very good with these signs, right, it will be very helpful in algebra because the signs, the plus, minus, multiplication, division, they all play a lot of they play an important role in algebra, especially the plus and minus ones. They play a lot of importance. It's very important to understand it well. So let's understand how to navigate this on a number line. If I may want to just quickly brief you on a number line. So if I draw the number line like this, 0, 1, 2, 3, 4, 5, say, okay, and you have a minus 1, minus 2 and a minus 3. So this is your number line. So on the right side you'll have all the positive numbers going up till infinity, and on the left side it will have all the negative numbers going up to minus infinity. So this is how it is, right? Right side is all positive numbers and left side is all negative numbers, and your head being the 0 over there. Okay, now let's look at this one. So this says plus 3 plus of plus 2. Now let's plot this one, plus 3. How do you do that? You basically go 1, 2, 3. You come here, right, with that plus 3. Now they are asking you to, they are saying that on the plus side, go another plus 2 positions. So I'm going to go here, I'm going to go here. What's my answer? Where am I going to land? I'm going to land at 5. So your answer is plus 5. That is what you have learned on a number line, right? Okay, let's look at the next one. They say that plus 4. Go 4 positions. 1, 2, 3, 4. I came here. I'm here right now. Now they are saying that no, go to the left 2 positions. So what I'm going to do? I'm going to travel left and I'm going to be coming here. So where do I land? I land at plus 2. So your answer is plus 2 over here. Now the third one is a little bit complicated, but let's keep it very simple. It's plus 3. So what I'm going to do? I'm going to jump to 1, 2, 3 and I come here. Now what are they saying is that no, go to the left. Go to the left towards to minus 2. You need to go to minus 2 from here. So if I go to minus 2 directly from here, so how many positions did I go? Can you check how many positions did I go? If you look at the magnitude, don't look at the sign right now. You have come from here, it is 1 position from 3 to 2, 1, 2, 3, 4, 5 and it's a positive 5 over here. Look at it, it's a positive 5. Remember to calculate the magnitude. How many places did you move from 3 to minus 2? That is how you see it. Remember this one very well, okay? We will come to this one later when we are doing multiplication. I'll explain you in a much better way, okay? Now let's look at the next one. Here it says minus 5. Go to minus 5. Suppose I draw minus 4 and a minus 5 over here, right? So they say that go to minus 5. So 1, 2, 3, 4, 5. I have come here. Now they are saying that add, go to the right side plus 3 positions. So I'm going to come here, I'm going to come here, I'm going to come here. So where am I? I have done minus 2. So your answer is minus 2 over here. Okay. So we are going to talk about all these things when I'm going to do multiplication. It's much more easier there to understand those values. But for the time being, understand this. Okay. Now look at this one. Go to minus 3 first. So 1, 2, 3. I came here. Now they are saying that no, go in the negative direction. Go in the negative direction because I have traveled in this particular direction. Go in the opposite. Whenever it is a negative sign, so you need to go 2 more positions over here. They told minus 2. So 2 more positions. So you landed plus minus 1. That's your answer. Okay? Makes sense? This is clear? Okay? Now, when we talk about multiplication, right, of 2 signs, basic rule you need to follow, multiplication. Whenever you have a positive times positive, it is always a positive. When you have a plus and a plus, it will always, for example, I have something called say plus 3 into plus 5. If you look at it, plus into plus will give me plus sign, 3 into 5 will give me 15. Remember this one always, okay? Similarly, a negative into negative will also give you a positive always, okay? For example, minus 3 times minus 5 will minus into minus, as I told you, it's always plus, so you put a plus, 3 into 5, it's 15 if you look at it, okay? And the combination of plus times minus is always minus, and minus into plus is always minus, remember. So these 4 things, if you can remember nicely, your algebra will be very good. Plus into plus is always plus, minus into minus is always plus, means what's the general rule? When both signs are same, when you multiply 2 signs which are same, right, you'll always get a positive. Similarly, when you multiply negative into negative, you'll always get a positive. And when you multiply a positive into a negative, you always get a negative. And when you multiply a negative into positive, you'll always get a negative. So for the time being, just remember these concepts, because I don't want to get into proving why this is this into this is equal to this, because you don't need to understand at this point. As and when you keep going to higher classes, you definitely understand these. Okay? Okay. Let's look at some addition and subtraction. Very basic problems. how to basically tackle these when it comes to algebra. Now look at it. In the first problem, what do they say over here? Add 3x, 4x. These are different terms separated by a comma. If you see here, they are separated by a comma over here. These are separate terms. So what do you have in this particular case? The first term is 3x. Okay, I'm going to put 3x plus, what is the second term? It's 4x. Okay. What is the third term? I'm going to put it as third term 7y. What is the fourth term? It is 5y. Right? You need to always include a equal to, plus 2z plus another 3z. Look at it. Now, can I resolve this? What are the like terms over here which you can add? These are like terms, right? So 3x plus 4x will give me 7x, right? I can do that simple mathematics. Similarly, what are the like terms in y? If you look at it, x is a variable, y is a variable, and z is a variable over here. So I can only add like terms. So 7 plus 5 is 12y, right? Similarly, plus 2z plus 3z is 5z. Can I resolve it further? No, I cannot, because these are not like terms. The variables are different over here. So this should be your answer. You don't go forward from here. You will not be able to do anything of that sort. So similarly, the next one, if you look at it, what do I have? I have a constant. Look at it. So I'll write it first. 4 plus 7a plus 3b, right? Plus 4x plus I have a 2a. I can write it here. Plus I have a 5b. Look at it. Instead of this sign, I can put it here. And then I have a 7x over here. I'll put it here, 7x. And I have 11. So I can put it as plus 11. Look at it. What do I get? I can add these two. Look at it. I have arranged them in order so that you'll be easily able to add them. So 4 plus 11 will give you 15. Obviously the sign is plus because both are plus over here. These two signs are plus, so it will be plus. Plus 7a and plus 2a as per the number line will give me plus 9a. Similarly, plus 3b plus 5b will give me 8b. Plus 4x plus 7x will give me plus 11x. So that should be your answer. Can you do anything further over here? No, you cannot add them because these are different terms. You cannot add them together. You cannot put it as 15 plus 9 like your 26, 26 plus 8, 34, 34 plus 11, right? 40, 45, 45. But what are the variables you're going to use? You cannot add them. So that's why you leave the answer as is. Got it? Very simple. Okay. Now look at subtraction. They say subtract 7x from 9y, right? So 7x from 9y. So your 9xy will come first, minus 7xy. Look at it. So what should be your answer here? 9 minus 7. These are two like terms. They both have the same variables and in a product x into y, that is. So you can do the math over here. 9 minus 7 will give you 2xy. Good? Plus 2xy. Okay? That is how the answer is going to be. So let me write it neatly so that it's understood. So this is subtract 7xy from 9xy, right? So that is nothing but it is 9xy. This is a positive sign, minus 7xy. So since both the terms are same, you're going to do plus 2xy. That's your answer, right? Come to the next one. What are they saying? Subtract 3abc from minus 7abc. So how are you going to write it? It's very important to write it properly. First you have to write this term, minus 7abc. I'll put it in a bracket. Whenever I have a sign over here in algebra, it's always to put it in a bracket so that you don't get confused. Now you are subtracting this one from this. So I need to put a subtraction sign and this term is plus 3abc. Look at it. So what should be your answer? Now look at it. What are you going to do? You need to go minus 7 positions to the left on your number line and then again you have to come in the reverse direction because you're subtracting, right? Remember that rule which I showed you? First you go -7 on the number line and then you need to travel 3 positions this side. So your answer is going to be -4abc. Remember. Okay? Similarly the other one, this is, what are they saying? They are saying subtract this quantity from this quantity. What is your first quantity? 26xy minus of -32xy. Right? What should you get over here? Similarly, you go -26 positions to the left of your number line, right? Then you have to change your direction and you have to go 32 positions to your right over here. Okay, so what happens? This becomes a positive, so this will give you 6xy. That's the answer. Okay, so multiplication and division is a little bit simpler compared to addition and subtraction in algebra. So look at it. I have just taken three examples of multiplication and division. Let's tackle this. So what are they saying? Multiply this quantity and this quantity. So whenever you see an expression like this in algebra, right, it is nothing but these are all your factors. For example, minus 3xy can be written as like this. This is -3 times x times y. These are factors of this particular term. Remember, you can always write it like this. These are factors. You have seen factors and multiples in mathematics, right? In arithmetic with numbers. In algebra also you can deal it like this. Okay, so let's expand this. What are they saying? Multiply this by this. So what can I do over here? I can write this as factors times, sorry, you need to always use this sign over here so that you don't mess up. So I have used a -3 already. X has a sign of positive x and y has a sign of positive y. Remember, times you have a positive 5 times a positive z. Now look at it. When you multiply all of them, the very first thing what you need to do is that you need to target the constants. What do you have? You have a minus sign and a plus sign over here. So minus into negative into positive always gives you a negative. Remember, I explained you earlier, and 3 into 5 will give you 15. Done? Now look at it. What do you have in terms of variables over here? You have a x, you have a y, and you have a z, right? You cannot multiply them. They are all variables. They have to be written separately. Look at the signs. What do you have? You have a plus. Plus into plus is plus. Again, plus into plus is plus. So what I'm going to do? X into y into z is nothing but it is x times y times z. That's the answer. Okay? For the first one. Similarly, if you look at it, how can you break this one? Plus 7 times plus x times plus y times plus z. This is the factors of this. Times, if you have a minus 20 times plus a times plus b times plus c, right? Now look at it first. What are you going to tackle? You're going to tackle the constants. Plus times minus is always a minus. 7 times 20 is 140. And if you look at it, there are all positive signs in front of it. So it will always be a plus. All are positives. Any number of positive signs into positive signs will give you plus. So you have x, y, z and then a, b, c. You need to write all in alphabetical order. So a, b, c will come first and x, y, z will come here. So this is the answer. Simple. Got it? Similarly, let's do the last one. What do you have over here? Now I'm not going to break it down like this because this is a waste of time. Writing like this is a waste of time. Now since you understood the concept, right, you can do it directly. -4 into -5 will give you what? Minus into minus will give you a plus. 4 times 5 will give you 20. And x into y into abc. So what are you left with? It is a, BCXY. That's your answer. In one line you can solve it. I hope this is very clear. I'm doing it at a very basic level and doing it like this. Okay. Now let's move to the division. So what are they saying? Divide this quantity by this quantity. So you're going to write it like that. -3, right? -3 times x times y. Here it's better to break it down into 5 factors. So it will become easy. So +3 times z, right? This is what. Now if you look at it, z and z are common, so you can cancel this out. 3 and 3 are common, you can cancel it out. Now what are you left with? Here you are left with 1, you are left with 1. So you don't have to worry about. You have a minus sign, leave it like that. You have a 1 over here, you don't have any constant, you are left with only xy. So your answer is -xy. Make sense? Easy? So similarly, let's go to the next one. What are they saying here? -36 times, it is x square. So you need to break it into x 2 times, right? Similarly, it is y cube. Y is 3 times if you look at it. Times it is z on the numerator. So I have broken down everything into factors, right? -36 is here, x square, so it is x into x. Y to the power 3 means it is y into y into y, and 1z, so I put it there. So now in the denominator you have a +9, into you have a x, into you have a y, and into you have a z. So there is 1z gone, z cancels out, 1y cancels out, 1x cancels out, and you have a 9 over here. So 9 4s are 36. Right? So what are you left with? If you look at it, right, what are you left with? You are left with a -4, put it here, -4. And what are you left there? X. And what are you left here? It is 2 y's left here. So you are left with y square. And what are you left here in the denominator? Nothing. This is 1, this is 1, this is 1, this is 1. So this is your should be answer. Okay? Understood? So let's do the last one and wrap it up. So you have a +27 on the top, and then you have a x, then you have 1y, and then you have 2 z's, right? Similarly, in the bottom you have a -3 times you have a x times you have a y, and times you have a z. So can we go ahead and cancel out? Z gets cancelled out, y gets cancelled out, x gets cancelled out. So what are you left with? This is 3. I can cancel out 9. Now look at it. You are left with only a minus sign in the denominator. You should not ignore that. Okay? And you have a positive sign on the top. Whenever you have a negative sign and a positive sign, right? The answer should always have a negative in it, since you are left with a negative. So you will always replace that positive sign with a negative one, and you have a number 9 over here. And what is left over here? You are left with z. Look at it. So this becomes 1. When you take this negative here, right, to the top, this becomes only 1. It becomes a plus over here. So your answer is this one. Great. I hope you liked the video. Okay. This is very basic, which I have covered. So I would request you to hit the like button and share it with your friends, so that more and more kids learn algebra in a much more easier way. Okay.